All right, good morning and welcome back. Today we'll start chapter 10. So if you haven't finished up the chapter test from chapter 6, make sure we get that done soon. So chapter 10 is dealing with area. Today we'll focus on triangles and a couple of the quadrilaterals, the rectangle and the parallelogram. If you need the notes, you know where to find them. Go to resources, go to chapter 10. It'll be in today's folder. Okay, so the folder for 42121. Okay, so let's start off the rectangle because I think most of you already know the area of a rectangle. Now, you might have grown up calling it length times width, and essentially it's the same thing, except we are going to call it base times height just because that way all of our shapes will have a base, all of them will have a height. Okay, but base is like our length times our width, so the area of this is the base times the height. Okay. Now, our next one, the area of a parallelogram. Okay. This one is going to have the same area, actually. Excuse me. If we think about it, this could slide over. If we move this triangle over here, it becomes a rectangle. Okay. So I have in our folder for today a 1 minute, it's only like 1 minute, just a 1 minute video that shows why this works if you want to see another example of this. But it's the exact same formula, just the base times the height. Now the key thing to remember here, the height and the base have to have a 90-degree angle between them. They are going to be perpendicular to one another. See how there's the 90-degree angle. So if we look down here on this first example, here is our height, 8. The base has to be 16. We don't actually care about this 10. The 10 does not help us. The 10 would be the side length. We need the base and the height to be perpendicular to each other. Okay? Just like on a rectangle, the base and the height have this 90-degree angle are perpendicular to each other. Then our final one, the triangle. Some of you probably already know this, but it's 1/2 the product of the base and the height. So A equals 1/2 times B times H, okay? And just like we said for the parallelogram, you see how the height and the base form a 90-degree angle here. So depending on how your triangle is oriented, your base and your height might be at a different spot. The key is they form a 90-degree angle. So we look here at this first one. It says state the name of the figure, then find the area. So the name of this figure would be a parallelogram. And technically, I guess it should have some marking so we know that. But we know each of these figures is either a parallelogram, a rectangle, or a triangle. So parallelogram. And we look here, the height is 8, which means the base is perpendicular to that is 16. So all we have to do is 16 times 8. Now 16 times 8 will give us 128. Now we need our label. So think about it, inches times inches, that becomes inches squared. All right, number 2. This one is also a parallelogram. Once again, base times height. Now, if it's parallelogram, if this is 9, we also know this is 9. So 7 and 9, we'll just do 7 is our height times 9. 7 times 9 gives us 63. Still going to be squared, so it's feet squared. Our area is always going to be whatever the label is squared. Okay, the next one. This next one is a triangle. So if we look here at our triangle, first thing we want to do is it's always 1/2 times base times height. So 1/2 times, now our height we see here is 7, and that's perpendicular to the base, which we need to add the 6 and the 10 together. If we add those two together, 1/2 times 6 plus 10, which is 16, okay, times that height, which we said is 7. So half of 16 is 8. 8 times 7 gives us 56. We know our label is squared, so inches squared. Number 4, another triangle. This one's a little easier than number 3 because there's only 2 pieces of information. 1/2 times base, which is times 12, times the height, which is 15. Half of 12 is 6. 6 times 15 gives us 90. And it's going to be 90 centimeters squared. All right. 2 more shapes here. Number 5. This one, be careful. Once again, it's a parallelogram. We need to be careful in that we identify the correct base. So parallelogram, oops, extra R there. So parallelogram, sorry, I can't write and talk. Okay, the height, hopefully you can see, is 12. Because remember, height, if you were measuring your height, you wouldn't lean against the wall and measure the diagonal, right? You want from bottom to top. Okay, so low to high. So that's 12 is our height. Now, 3.5 will have to be the base. That would also be here. That is perpendicular to that height. So just 3.5 times that 12. So 3.5 times 12, that will give us 42, our label squared, so millimeters squared. All right, and our final one, once again, a triangle. This one, the base and height have to be perpendicular. So you see the right angles here. Our height 2.5, our base is 11. So it's always 1/2 times the base times the height. So 1/2 times 11 times 2.5. So that will give us an answer of 13.75 feet squared. All right, just a couple more examples. This next one doesn't have a picture, but it's pretty easy. It describes it to us. It says a triangle has a height of 5 centimeters and base length of 8 centimeters. Find its area. I'd say this is easier than the other ones we did. All we got to do is 1/2 times the base times the height. So half of 8 is 4. 4 times 5 would give us 20 centimeters squared. Okay. Now your next one, once again, a story problem. It says Fran designed a flag that measured 9 inches in length and 5 inches in width. Find the area of the flag. Okay, so a flag, not all flags, but the majority of flags we know are rectangular. Okay, so it tells us that it is 9 inches in length, 5 inches in width, or in our case, base times height as we're doing. So 9 times 5, that'll give us 45 inches squared as our answer. All right, now the final one. And this time it tells us what the 2 shapes are. It won't always. If we have a picture like this and we're trying to find the area, do you see how there's a line right here? We can treat this as 2 separate shapes. Okay, worry about the parallelogram, then worry about the triangle, then we'll add them together. So if none of this junk was here for the triangle, the height of this parallelogram is 18. It forms a right angle with this bottom. We know it's a parallelogram, so 40 and 40. So to find it, we just take base times height, or in our case, 18 times 40. Now, remember, if you can't do this, that is fine. Use your calculator. Remember, desmos.com/scientific. So 18 times 40. I hit enter, that's 720. Okay, now 720 meters squared. Once again, remember, I use 18 and not 22 because 22 is this diagonal. We don't care about the diagonal, we care about that height. As if this little part, if I would move this part that I shaded in over here to where I shaded it in red, do you see how it would match up with that? Okay. Now, obviously, we're not going to move it, but that is why it works. Okay. Now let's figure out the triangle and we'll add them together. So plus, now for the triangle, it's 1/2 times the base. The base of the triangle is 50. The height of the triangle is also 18. So 1/2 the base times the height, or in our case, 0.5 times 50 times 18. We get 450. So plus 450 meters squared. If we add those two together, 720 and 450, we will get 1170, and it's still meters squared. We're adding those, so don't become meters to the fourth, right? Because this is like 720 apples, 450 apples. You don't get double apples. Okay, the label is the same. If we're adding, the label stays as is. And here will be our final answer. So if you ever have a shape that is made up of other shapes, you can just divide it, find the area of each of them, and then add them back together. So there is an It's Learning assignment. Please get that done. If you have any questions, let me know. Hope you guys have a great day, and take a look at that 1-minute video if you're wanting to understand why parallelograms and rectangles have the same area.